Question number 32. A charged sphere is in a gravitational field and then initially stationary between two metal plates, charged plates. There is a potential difference V between the plates. There is a potential difference V between the plates. Okay. And the charge 3 changes can be made like this, which changes will separately cause the charge sphere to accelerate. That means, okay, which one will accelerate. So towards it, see, if this is a charged sphere, mg will always act downward like this, right? So in order to counteract this mg force, what should happen? The electric field that is being present over here should be upward like this. Okay, so if this is upwards, then it's possible. So when can this be upwards? When this can be, electric field can be like this, which means minus q should be the charge of this. Either the charge sphere should be negative, or maybe if this is positive, then this should be negative like this. Okay, let me assume for time being this is plus q over here. So therefore, now the electric field experienced by this one in this electric force experienced by the charge in this direction is nothing but q into E, right? So what I will do is I will write down the equation. Q into E should be equal to mg. If this condition is achieved, definitely this will be hanging there. It will not move downward nor will move upwards. We also know that electric field E is given by potential difference divided by the distance between the plates. If I substitute it over here, I get QV divided by D is equal to mg. Okay, so this mg will be balanced if this condition is met. Now let us read the options. Increasing the separation between the metal plates. If D is increased, what will happen? This quantity becomes lesser. When this quantity becomes lesser, then what can happen? That means the force here becomes lesser, and thus mg would be greater than qv by D if D increases, right? If D increases, this becomes larger, and as a result of it, the charge will start coming down. The sphere will start coming down like this over here. Okay, so it will accelerate. So this is true. Then increase V. If I increase the V, what will happen? Now this will try to go upwards over here, right? Because this potential is larger, so it will get attracted more and more over here. So definitely it goes upwards. So therefore this is no more stable. So this is also true. Applying a magnetic field into the plane of the paper. If you apply a magnetic field already, so there is a charge over here. Don't expect it to move like this. The reason is because it's a stationary charge, right? The force acting on a stationary charge is given by qvb sin theta. If the velocity of the charge is 0 initially, then what can happen? This becomes 0 over here. There is no force acting on it. By Newton's first law, if no force acts on it, the particle will not move, right? Which means it will still continue to stay there. So therefore, if you change this one, then definitely it will not accelerate. So this is not the right one. Okay, so if you want to accelerate, either you increase the separation or you increase the value of V. So this 1 and 2 are the right options. Okay, let us move on to